floating point number and type decimal. C# provides three simple types for storing real numbers: float, decimal, float, double, decimal. The type float and double are called the floating number type. The primary difference between them and the decimal is that the decimal variable stores a limited range of real number precisely, whereas floating variable store only approximations of real numbers, but across a much greater than range of values. Also, double variables can store numbers with larger magnitudes and finer details. Variables of type float represent single precision floating point numbers and have 7 significant digits. Variables of type double represent double precision floating point numbers. These require twice as much storage of float variables and provide 15 to 16 significant digits, approximately double the precision of float numbers. Variables of type decimal require twice as much storage as double variables and provide 28 to 29 significant digits. And when we use decimal, most programmers represent a floating point number with double, and C# treats all real number you type in the app source code as double value by default. Such value in the source code are known as floating point literal. To type a decimal literal, you must put a M, lowercase uppercase, stands for money, at the end of the real number. Integer literals are explicitly converted to type float, double, and decimal when they are assigned to a variable of one of these types. At the end of our book, you can see the simple type list. Right here, a bool, the size is 8 bits, byte 8 bits, aspect short byte 8 bits, char 16, short 16, unsigned short, U short 16. These are positive numbers. int 32 bits, unsigned integer, positive number 32, float 32, long 64, U long, unsigned long, called unsigned long 64, double 64, decimal 128. You can see the range is different. It's a big difference like this. And if you want to know more about it, go to this URL to see the more information about this number system in C#. Most of the time we use integer, float, double, decimal. I believe most of the time we use decimal. 2 digits are enough. Unless you want to give more range, you pick up a float or double. That's the number system in C#. Now let's look at a example in our book called account. And there's also some formats about the number system. C, format string as currency, display appropriate currencies, $sign, lowercase c or uppercase c. D, format string as whole number. N, format string with 1,000 separators. E, format number using specific scientific notation with default 6 decimal digits. F, format string with a fixed number of decimal place. G, format number normally with decimal places or using scientific notation, depends on the context. X, format string as hexadecimal. Alright, let's look at the class account. This is the account in our book example right here, and class account and the test. There are two. Account has data member, decimal, balance, private. So it must have property get inside. Notice the property here, get block, nothing special, just return. Set block, we added a if condition here. If we're going to talk about the if again in chapter 5. If statement, if this is true, then we put value in. So it means the set block receives the value, but we only want to receive a positive value, which is greater than 0. Greater than or equal to 0. So here we have condition here. That's why sometimes we don't depend on the automatic property. Instead, we want to have our own version of a property. So we have to write code right here like this. So that's the property for balance. And then it has method account. The constructor account. The type is decimal. Passed into balance. And we have method credit, decimal, balance plus the amount. Notice here, balance and balance. Balance and balance. What is balance here? Balance is the property that we have right here. So we have balance equal. Which one is balance? You know, property has a get block and a set block. So we say this is the. How do you know this is the get block or set block right here? How do you know it? Remember I told you right here. I say I put the code in the other way. So I'm gonna write it right down here again. Right here. This balance is on the left side of equal. So it is what? On the left side equal, it receives value. So receives, it does receive. It is what? It is set. And this one is on the right side of equal. Right side of equal. It returns. So it is what? It is get. So that's how you know which is the get block called or set block called. So that's the little program here. When I look at the test, here we say we create account 1, account 2, and both has the parameter passed into constructor. So both balance has the value. Both has the value, and now what we do is both has value, and then we just retrieve the value using get the balance for both of them, and then we create a variable called deposit amount, and then we pass the value to deposit amount, and then we display deposit amount convert it to decimal, to decimal, and then account 1 get the deposit amount, and we show it. And then we have deposit amount 2, and then we call deposit amount for account 2. We'll show it here. So when I run it, I get this one here. I'm going to slow down and see how the program runs. Right here, see account balance 5 and 0. How do we know? How do we get this one here? Because we put 50 here, we put the 7 here, and look at the account class. Look at the account class right here, balance, and this constructor account, which is called right here, 50 and -7. Let's look at account 1, get a 50. Because when we do this here, we're calling constructor. The constructor is right here. It passed the value to a balance, which is the property. But look at the property here. When you set value, it only receives the value if it is greater than 0. So 50 that we passed here is greater than 0. So 50 is passed to the data member balance. It happens right here. So when we print account 1 balance, then 50 should be returned right here. That's why we see 50. But we see 0 here for account 2. Why? Account 2 is right here. -7 and pass to constructor. The constructor get a value right here. But remember, it's on the left side of the equal. So we're calling the set block, but the value here is evaluated with if condition. If it's greater than or equal to 0, -7 is not greater than or equal to 0. So this block is not executed. It doesn't do anything. Nothing happened right here. For this, nothing happened. -7 is not saved into the data member balance, and that's why it returns the balance calling the get block returns 0 because the default value is 0. The default value is 0. Here you can see :C:, it returns the $sign. That's why we see it right here, $sign. Next, create a variable deposit amount. Then we pass deposit amount to account 1, credit. So credit is right here. Credit get a value and balance plus the amount. That's new balance value. Update the balance value, and then here I'm going to do this. I will say 20. I hit enter. Now I get a 70. Why do I get a 70? Because it does addition. 50 plus 20, 70. So that's why when we call the property here again, balance, we get a 70 here. We get a 70 here. Right here, get 70. And when we print out the account 2 balance, it's still 0. Now say enter deposit for account 2. If I enter negative value, account 2 will be 0 again because account 2, because the set block only receives the value greater than or equal to or greater than 0. So this time I enter a positive value here. I say enter 5. So now you can see it display the balance value again for account 1, account 2, 70 and 5 because I entered 5, and this time when I enter 5 for account 2, credit deposit, which this time is this is the 5. So 5 is passed to is passed to credit. Credit is 2. So 2 plus balance, 0 plus 5 will assign the value to the balance, and this time we do evaluation again. 5 is greater than 0. Yes, we got it. So we save the value of 5 to the balance. That's why right here we display balance 2, and we can see the 5 here. And that's how this program works.